Hello friends, welcome to this video session of Microprocessor part 2. In this session we are going to study about pin representation of 8085A microprocessor. 8085A is commonly known as 8085 microprocessor. It is a 8-bit general purpose microprocessor and is capable of addressing 64K of memory. This device has 40 pins and requires plus 5 volt single power supply, and it can operate with the 3 megahertz single phase clock. And here we have the pin representation diagram of 8085. Firstly, we'll study about the address buses. The 8085 has 16 signal lines, that is 16 address buses that are used as the address buses, and these lines are divided into two segments. First is 815 to A8. You can see here it is A15 and here it is A8. These signal lines are unidirectional and used for most significant bits, and these most significant bits are called the high order address of 16-bit address. Next we have the signal lines AD7 to AD0. The signal lines AD7 to AD0 are bidirectional, means they serve as dual purpose. They are used as low order address buses as well as the data buses. In executing an instruction during the earlier part of the cycle, these lines are used as the low order address buses, and during the later part of the cycle, these lines are used as the data buses. And this process is means during the earlier part of the cycle, these lines are used as the low address buses, and during later part of the cycle these lines are used as the data buses. This is known as multiplexing of the bus. Now next we have the control signals. This group of signals includes two control signals. First is read and second is write. In the diagram we have 32 number pin is read signal and 31 is write signal. These are the control signals, and we have three status signals. The 34th is the I input, output and memory, and the 33rd is the S1 and 29 is S0. These three are the status signals. And the 30th is special signal, which is ALE, and it is also known as address latch enable. Now we'll start from ALE, the address latch enable. This is a positive going pulse generated every time the 8085 begins an operation. It indicates that the bits on AD7, means the bits on AD7 to AD0 are the address bits, means this time they behaves like address buses, and this signal is used primarily to latch the low order address from the multiplexed bus. And next we have the read signal, this one. This is a this is a read control signal, and this signal indicates that the selected input, output or memory device is to be read and data are available on the data bus. And next we have the write signal, the 31st pin. This is a write control signal, and this signal indicates that the data on the data bus are to be written into a selected memory or the input output location. Next we have input output memory. This is a status signal and it is used to differentiate between input output and memory operations. When this pin is high, it indicates that an input output operation, and when it is low, it indicates a memory operation. Next we have S1 and S0. Status signals similar to input output and memory, and can identify various operations. Next we have power supply and clock frequency signals. First we have the VCC, the 2 number pin, and it is a power supply pin, and it requires 5 volt power supply plus 5 volt single power supply. And next we have VSS, it is a ground reference. And next we have X1 and X2. With the X1 and X2 pins, a crystal is connected, and the frequency of internally divided by 2 means the frequency of the crystal is internally divided by 2, and to operate a system at 3 megahertz, as we already know, this microprocessor is 8085 can operate at 3 megahertz, and to operate this system the crystal should have a frequency of 6 megahertz. And next we have the clock output signal. This signal can be used as the system clock for other devices. Next we have externally initiated signals and the interrupts. 8085 has 5 interrupt signals. The first one is the interrupt request, and this is INTR, the number 10th pin of the microprocessor. And it can be used to interrupt a program execution. Next we have the interrupt acknowledge, INTA, the 11th pin of the microprocessor, and this is used to acknowledge an interrupt request by the the INTA is used for acknowledge the interrupt request. And in addition to the interrupts, 3 pins, the reset, here it is the reset, and hold means a HLDA, and ready. These are the initiated signals, and these are used as the input. HLDA is not in this category. Hold, reset and ready are used as input, initiated signals as input. And to respond the hold request, the 8085 has HLDA, means it this is known as the hold acknowledge. And we talked about the reset signal, and reset has 2 signals. First is reset in and the second is reset out. Reset, when the signal on the pin goes low, means we are talking about the reset in. When the signal on this pin goes low, the program counter is set to 0. and the buses are tri-stated, and the microprocessor is reset. And when we talk about the reset out, if this signal indicates that microprocessor is being reset, and this signal is also can also be used to reset other devices. And we have the two serial input output ports. First is SID and the second is SOD. SID is serial input data and SOD is serial output data. With this we came to the end of this topic. Thanks for watching.